Hi everyone, welcome to geometry class. Today we'll be in chapter 3, section 1 of our textbook, studying lines and angles. So open your textbook and follow along starting on page 146. Today, at the end of this video, you'll be able to answer the following questions. How do you identify parallel, perpendicular, and skew lines? How do you identify parallel lines? What is a transversal, and what are the angle pairs created by a transversal? Let's start by imagining that you're designing a new building. You want to make sure that the builder gets everything right, so you're making sure the blueprint you're giving the builder is completely correct. So let's imagine this figure right here is the blueprint you're giving the builder. So let's discuss what each of the pieces of this blueprint are. The first item we'll want to look at are parallel lines. So parallel lines are coplanar. That means that they are on the same plane and they never intersect. So let's look at a pair of parallel lines. We have a pair of lines right here that are parallel. So we can write that right here. Line AB is parallel to line EF. And I'm using this symbol right here to show that those two lines are parallel. Make sure I have my lines right there. So on the figure, let's look at how we show that lines are parallel on the figure. We have these arrows right here, and those arrows tell us that those lines are parallel to each other. So we can also find another set of parallel lines. We have one right here. See these two arrows? So we have lines EG is parallel to line FH. So you'll notice that there are two sets of arrows on lines EG and FH, and only one set of arrows on line AB and EF. So the different number of arrows tells us that each set has, if they're parallel, has the same number of arrows. So if you see two lines that look parallel but don't have any arrows, you cannot assume that they are parallel to each other. Okay, then are perpendicular lines. Perpendicular lines intersect at a 90-degree angle. So we can see the 90-degree angle symbol right here, and that tells us that line AB is perpendicular to line AE. And I'm writing out this perpendicular symbol right here. And in writing, that tells me that those two lines are perpendicular to each other. On the diagram, this 90-degree angle symbol tells us those two lines are perpendicular. You'll also notice there's another set of perpendicular lines right here. So line EG is perpendicular to line GH. Perfect. Just like in parallel lines, if you see two lines that look perpendicular, but they don't have the 90-degree angle symbol, you cannot assume that those two lines are perpendicular. They must have the 90-degree angle symbol. Okay. The next set of lines that we're going to look at are skew lines. Those skew lines are not coplanar. That means they're not on the same plane. They're also not parallel, and they'll never intersect. One way to look at skew lines is, let's imagine that you're riding up on an elevator, up right here. And you have a friend that's walking along the floor over here on the other side of the building. Well, your path and your friend's path will never intersect. They also are never on the same floor. The lines are never on the same floor. So your two paths are skew. So what we just said, lines FH is skew to line AB. Okay, we can also find another set of skew lines. There's several in this figure. Another set are lines EG is skew to line CD. Okay, very good. The last thing we'll look at on your blueprint are parallel planes. Parallel planes are planes that never intersect. So you can imagine that parallel planes are like floors on a building. So the first floor and the second floor, they never intersect. They're right on top of each other. So plane A, B, F is parallel to plane C, D, H. Those two planes never intersect, so they are parallel planes. Okay, so we want to make sure that we understand all the pieces that go into your blueprint so that your building does not end up looking like this one. This building was actually built on the MIT campus, and MIT is suing the architect that designed this building. Okay, let's step back from your blueprint for a second and look at the streets surrounding your building. So this top picture is an aerial shot of New York City. So we have a street that runs down the shot right here, and then two streets that run left to right here. Okay, so we can imagine that those streets are represented by this figure right here. Okay, so the way these streets are placed have a large impact on the design of the buildings that lie in between the streets, like how large their foundation can be. So let's take a look at what happens when these lines intersect. We'll first look at this line right here that's running down the picture. That line is called the transversal. And that line intersects two lines that are on the same plane or are coplanar at two different points. So on this figure right here, line T is the transversal right here. Okay, when line T intersects the two other lines, lines R and S, there are 8 angles that are created by their intersection, and we can classify those angles as angle pairs. So let's take a look at those angle pairs right now. The first set of angle pairs are corresponding angles. So it's an angle pair, that means there'll be 2 angles. The corresponding angles lie on the same side of the transversal. So again, here's our transversal T. They're on the same side, and they have the same position next to the 2 lines R and S. So let's take a look at what that means. So angle 1 right here is on the top side of line R, and angle 5 is on the top side of line S. They're both on the same side of the transversal T. So angle 1 and angle 5 are corresponding angles. There are 3 other pairs of corresponding angles on this picture. Let's take a look at what those are. Angles 3 and 7 are corresponding angles. Angles 2 and 6 are corresponding angles. And angles 4 and 8 are corresponding angles. Okay. The next set of angle pairs we'll talk about are alternate interior angles. So those are several large words, so let's break this definition down. Alternate means opposite, and interior means inside. So let's take a look at this figure really quickly. We have spaces that are exterior to lines R and S, that I've outlined right here, and then we have a space that's interior, and that means that it's inside the 2 lines R and S. So the angles we're looking at right now are inside lines R and S. Alternate meaning they're opposite. So let's look at this definition. Alternate interior angles are non-adjacent angles that lie on opposite sides of the transversal T between lines R and S in the interior. So angle 3 and angle 6 are alternate interior angles. They're not adjacent to each other, and they lie on opposite sides of the transversal inside lines R and S. One way you could think about this as the 2 angles that are the farthest apart from each other that are still inside the 2 lines R and S. So we also have Angles 4 and 5 are alternate interior angles. Okay, very good. The next set of angle pairs we'll look at is similar to the first in name, but they are different angle pairs. They're called alternate interior angles. So the same thing, alternate means opposite. Exterior, we're looking at what's outside of the two lines R and S. So alternate, opposite, the two angles are on opposite sides of the transversal and outside of the lines R and S. So if we pick angle 1, the angle that's on opposite side of the transversal T and outside of the lines R and S is angle 8. So angle 1 and angle 8 is the angle pair that are alternate exterior angles. We also have angles 2 and 7 are alternate exterior angles. Perfect. The last set of angle pairs we'll look at today are same side interior angles. Let's break down that name. Same side, of course, it's going to mean they're on the same side of the transversal, and they're interior. They're on the inside of lines R and S. So if we pick angle 3, then angle 5 is going to be its same side interior pair, angle pair. Okay. Angle 4 and angle 6, likewise, are same side interior angles as well. Okay, perfect. Practice. We have this figure right here, and what I want us to do is identify the transversal and classify each angle pair that are given right here. So let's start with angle 4 and angle 6. We have angle 4 and angle 6. The first thing we need to do to identify the transversal is look at the line that touches both angles. We have this line right here, line P, and that touches both angles 4 and 6. So that's going to be our transversal, line P. Well, those two angles are on the same side of line Q and line R, and on the same side of the transversal P. So they are corresponding angles. Perfect. Okay, let's look at angles 1 and 2. Here's angle 1 and here's angle 2. Again, let's identify the transversal first. So it's this line right here, line Q. That is the line that's touching both of those angles. And those angles are on, if you look closely, the interior of line R and line P. So let me erase that now. But they're on opposite sides of the transversal. So those two angles are alternate interior angles. Perfect. All right, now let's look at angles 3 and 4. Erase this. So angle 3 is here, and angle 4 is here. The transversal, again, is touching both angles, so that's line P. And those two angles are on opposite sides of the transversal and on the outside of lines R and Q. So they're going to be alternate exterior angles. And then finally, let's look at angles 6 and 7. Angle 6 is here and angle 7 is here. The transversal is line R. And those two angles are on the same side of the transversal inside lines P and line Q. So they are going to be same side interior angles. Perfect, guys. Good work. Review. You've learned how to identify parallel, perpendicular, and skew lines. You've learned how to identify parallel planes. And you learned how to identify a transversal and identify the angle pairs it creates. Now take a look at the vocabulary words that we've discussed today and make sure you've written down the definition as well as an example. Good work today, guys.